Hi and welcome to SYS Systems. I'm Rob Thompson, the Sales Manager here at SYS Systems, and I'm joined today by Matt Jones, Senior Applications Engineer from Stratasys. In this video we're going to talk a bit more about the P3 technology and specifically the Origin 1 machine. So Matt, could you give us a bit of an overview first and foremost of P3 as a technology?
Yep, so the P3 is a DLP process, a digital light projection, and it's basically a bottom-up approach. So we have a projector, UV light source underneath, with a tray of resin and a build head or an arm that comes down, and you build out of the resin. So it's, I call it quasi-dung compared to stereolithography, which is in a big, top-down with a laser. DLP is a bottom-up approach, which gives you the option to do really high detailed, amazing surface quality and accuracy of the models it can produce.
So is DLP a process that's been around a long time?
Yeah, it's a very well-established process. So it actually came out of Germany a long time ago, and Stratasys saw that we had a sort of gap in our product portfolio, so we acquired a company called Origin, a US-based company. But the thing with the DLP process that we sell, it's aimed at manufacturing and end-use parts, not just prototyping. Yeah, it can do all the usual prototyping, but because of the type of light we use, the wavelength, we can do some really amazing materials, really strong end use, high impact modified FST based materials for automotive or for aerospace. So it's taking what used to be predominantly for sort of like hearing aids and dental and things like that to other industries.
Right, okay, and that's really material driven, is it, with this type of technology?
Yeah, along with the actual hardware. So when you look at other DLP systems, it's very much like our FDM range. We have an oven temperature controlled, exactly the same thing on the Origin, on the P3 machine itself. Being able to control the oven, the separation forces, being able to monitor what's going on inside the machine, so the exothermic reaction when we expose the light and see the chemical change in the materials, gives us the ability to print very accurate, very strong parts. So the green strength, so when it comes out of the machine before you post-cure it, it's very, very high, which gives you much better accuracy, less chance of warping and distortion and things like that.
Right, so for those not really au fait with the DLP process, unlike Polyjet, where the part is fully cured and ready to go off the machine, there's a bit more of a process.
There's a little bit more to it, yeah. So there's a little bit more pre-processing as well. So with Polyjet, you literally bring your file into GrabCAD and you orientate it, you choose your materials and you press print. Really, really simple. With stereolithography and P3, you need to orientate it and also choose a support material. That's normally done in like Materialized Magics or NetFab, but also within GrabCAD, which will be coming out later this year with all the support structures on there. So you need to choose, for example, the A face or the B face, or the surfaces where you don't want supports on. So anything, for example, on this top face here, we don't want support, so it's supported underneath, and you're left with these sort of small little pips that you have to sort of sand off afterwards. But part of the post-processing is that you have to wash the parts and UV cure them as well to make sure that they're fully cured and safe to handle.
Right, okay, so the key really there is that we are actually coming off the machine with a higher cured percentage, higher, yeah. Which I suppose when you're handling these parts means that you've got less chance of breaking them or warping the parts.
You'll find that other materials or other options out there, when you print something and you may ship it, you may find it's broken when it's arrived, or it's doing whatever it's doing in its end use application. Materials we have, there's a 3172, which is a high impact modified nylon 66 like material. You can smack it as many times as you want and it's not going to shatter or explode. Typically, when you look at other photopolymer materials out there, they're not as strong or mechanically stable as other materials like FDM, for example. By far the strongest, robustest sort of materials we have. P3 is very close second.
Amazing. And you get then the added benefit of the surface quality and feature detail with this type of technology as well.
It's like injection molded quality, and the accuracy is phenomenal.
Yeah. And I suppose that leads us on to one of the other sort of advantages of this type of technology, which is the speed of printing against maybe other processes. So FDM, we are pretty much, if a part takes a couple of hours, 2 parts are going to be 4 and 3 is 6. Whereas this is a little bit different in the way that it prints, isn't it?
Yeah, so because you're using digital light, you can fill the platform with as many parts as you want, and basically it takes a black and white image, the white image being the bit that's going to cure. So you might as well maximise the amount of parts printing on a build in one go. The only determining factor for print time is the Z height. So it doesn't matter how small or the larger the cross-sectional model is, it takes exactly the same time to cure that individual slice.
Perfect. So that really then makes this perfect for serial production, you'd say?
It does, yeah. I mean, if it's small connectors and things like that, you can do 20, 30,000 a year of them if they're small. You can stack them in Z, so you're not just doing one height, you can stack them throughout the build as well. So it gives you the big production, not as good as the SAF. The SAF technology, the powder-based system that we offer, you're getting a lot more out of there, but it's a much bigger build platform, different process of working. But for connectors and things, yeah.
So I suppose when we're looking at mass customisation, complex parts, reducing tooling costs, this would definitely be a technology to have a look at.
Yeah, tooling costs, I mean, you might not pick it up on the camera, but the surface detail, the details on this are phenomenal. You can go on the website and have a look at it in greater detail, but you can't do that from injection moulding. That type of quality, trying to make that machining the tool, the cost, the time involved, it's a crazy amount.
If you need 500 of a particular connector and then another 500
Yep.
with a slightly different pin configuration, if you can qualify these materials within your process, then this is going to be really something perfect.
If you've got old equipment out there that you can no longer get the spare parts for, the supplier's gone bust or something like those lines, you can reverse engineer a component and print it, in a material that is pretty much the same as you would do from an injection molded machine as well.
Fantastic. It really does seem a really interesting technology, and something that I think within the manufacturing area this is going to really take off. Would you say then again the materials is key, and where's this going to go with materials going forward?
It's an open system, so you don't have to purchase or use the materials that we recommend. There are again validated materials as well, but there's a fully unlocked version. So people like Henkel, BASF, they use the machine to develop their own materials, which is a great thing for us because the freedom and the use that you have from it means that the people that actually make the materials are using it to develop them on our processes, and it's all locked off as well. So the more development we get, whether it's for medical, whether it's for aerospace, it's perfect. They all do the qualification for you to make sure for skin irritation, cytotoxicity, all those sorts of things are done. So you can take a material, put it in a machine and run with it.
Amazing. And I think at Formnext last year we saw it might have been 6 or 8 Origin ones being fed by a robot arm. So
Yeah.
automation is maybe the next sort of area where this is going to be utilised.
Yeah, because it's a little bit more tricky to handle than polyjet, for example. If you're doing a large adoption of it and you need the quantities, you don't want to have to be pulling supports off and washing it in a wash tank by hand. So being able to offer an automated process where a robotic arm comes in, it takes it off the head, takes the supports off for you, washes it for you, it cures it for you. It's a massive value added.
Amazing. So yeah, this is going to be a technology really that we see not just for prototyping, definitely going to be utilised within the manufacturing area for low volume, serial production, even for certain size parts. So if you've got an application where you think this might be suitable, then please do get in touch with us. We can have a look and evaluate the parts and maybe see if there's any redesign on there, and we can have a go utilising the Origin One system.